I've got my side thing on. There we go. I have slides. Thank you. Goodbye. Okay, so this talk is 7 reasons why I accidentally called it why I'm not leaving .NET. It's not, because I've got my daughter doing this talk with me. So it's why we're not leaving .NET, because I see blog posts, why I'm leaving .NET. Because you can't just leave and start programming in Go or Ruby or Python or something. No, you have to write a big blog post explaining exactly what Microsoft has done to annoy you and offend you. And I'm not leaving .NET, and these are 7 reasons why .NET is basically the coolest thing in the world right now. It is hot. Yes, it is. Shut up. I'm preaching to the converted here, I know, but I'm going to try and show you some cool stuff in the time that I've got. But I'm going to start with a quick history lesson, because it's good to look back over how we got to where we are with .NET. And so we've had lots of .NETs over the years. We had the first .NET in 2002, which was .NET 1.0. And if you don't remember that far back, .NET 1.0 didn't have generics. And so the only mutable list, the only thing you could add to was an array list. And when you did an index on that, you get an object back, and then you'd have to cast it. And the same with hash tables. We didn't have a dictionary of key value. We had a hash table, which was a dictionary of object. And so that was fun. And then in 2005, we got .NET 2.0, which did have generics. And actually, it only had generics because of F#. The only reason we got proper generics in .NET is because of Don Syme and F#, because functional programming languages really need generics, and they need proper ones. 2007, we got .NET 3.5. I'm skipping .NET 3 because Microsoft basically skipped it, so fair enough. But that gave us WPF, which was a whole new paradigm for memory leaks. And it gave us a link, which was a fantastic way of writing expressive code that ran really slowly and allocated loads of objects. Then in 2012, we got .NET 4.5 and we got ASP.NET MVC, so we could finally write web applications like they were web applications and not like they were Windows Forms applications, and we got rid of view state. That was cool. And in 2016, we finally got .NET Core, and suddenly Microsoft actually had a first-party .NET implementation that ran on Linux, and it ran on Mac, and they released VS Code so you could edit it on Linux and Mac, and it was completely open source. If you use .NET Core, then there is a little bit of code in there when you're running .NET Core that I wrote because they accepted a pull request. It was like 3 lines of code, but they accepted the pull request. Who else has had a pull request accepted to any of the .NET or ASP.NET projects? Few people? Just yes, you know, they love it. Just go in there and go, I fixed that for you, and they will thank you. Even if it's just the docs. I fixed some docs the other day, that was great. Along the way, we've had other .NETs as well. So we've had Mono, because Miguel de Icaza, who is quite possibly one of the smartest people in the entire world, looked at .NET and went, oh, that C# looks really nice. I wish I could program in C# on Linux. And while most of us would have gone, and off to watch TV, he built his own implementation of .NET that ran on Linux just so he could use C#. That's how much he liked it. And he put WinForms in there, and it did web forms and everything else. And in 2007, we got Silverlight. Who loved Silverlight? If you really miss Silverlight and you wish it hadn't gone away, take some solace in the fact that .NET Core is basically Silverlight. They just finished it. And we had the .NET Micro framework. I actually wrote some code in the .NET Micro framework that ran on a fridge. And it would ask a web server whether it was OK for the fridge to turn on. And the web server would say, no, wait 10 minutes, because energy spikes. And that didn't even have an HTTP client implementation, so we had to write our own over TCP sockets. Difficult. And in 2011, Xamarin kind of grew out of the Mono project, and suddenly you could use C# and Mono to build iOS and Android applications and eventually Mac applications as well. And in 2014, we got UWP, the Universal Windows Platform for building apps for Windows 8. Hands up, who's built an app for Windows 8? Yeah, right. Oh, blimey, some hands. Put enough people in a room, you'll get at least a couple. So now we're heading into 2019. It's the end of 2018. It's been, yes, it was worse than 2017, which was worse than 2016. Obviously, that's from a British perspective. Things are not good. Can I come and live with you? Please. But in the .NET world, things could not be better because we've got .NET Core. We've got .NET Core 2.1 now, and .NET Core 2.1 is astonishing. You can run .NET Core on Linux and Mac and Windows. You can run it in containers. You can run it in all the serverless things. If you go and check the stats, .NET Core 2.0 is actually the fastest runtime for AWS Lambda, for example. You can do ARM builds, so you can compile it and run .NET Core applications on Raspberry Pis and microbits and all sorts of weird things, robots. Samsung actually looked at it and went, that looks really cool. We're going to make the Tizen SDK for our smartwatches and smart TVs and everything. We're going to base that on .NET Core. So Samsung have actually contributed a bunch of code. Don't worry, Microsoft reviewed it, so it won't be like the Samsung Android skin. We also have .NET Standard, which is very confusing, but seems to be quite good. .NET Standard lets you write a library and then reuse it in lots of different platforms. You can use that in Xamarin for mobile applications. You can nearly, almost entirely properly use it in Unity 3D. And you can even compile it to run in the browser as WebAssembly, which is completely nuts. Also, you can compile it to run as WebAssembly inside Node. Yeah. I don't know why you do that, but you can. The performance is one of the key things with this. When Microsoft first came out with what eventually became ASP.NET Core, it had the Kestrel HTTP web server. And Kelly Summers, Kilobyte, benchmarked it. And she had a web server that she'd written in C, which could do like 100 million requests a second on this server that she had. And she benchmarked Kestrel on the same server, and it could do like 70,000 requests a second. And she went, why is it so slow? And according to Damien Edwards, he went to the team who were building it and said, why is Kestrel so slow? And they said, you didn't tell us you wanted it to be fast. And he went, right, you see this, Tech Empower? I want us up there. And they went, right, we'll do that. And now, the plain text test, in the most recent Tech Empower, it's number 11, but there's like 1 percentage point covering the whole of the top 15 or something. The really nice thing now is that real applications using databases have got fast as well. So we've got the PostgreSQL provider is all optimized and sped up, and now the Fortunes test on Tech Empower actually does a query against a database and returns data out. And so we're number 7 in that at the moment, which is really cool, because that's proper speed, that's representative of stuff. And part of the reason for that is that in .NET Core 2.1, they introduced these new memory APIs. Has anyone actually played much with these span-T, memory-T, these sorts of things? They are astonishing, because one of the big problems with performance for .NET and for Java and for Go and the dynamic languages is garbage collection. You create a bunch of objects and something comes along and cleans them up. And it's non-deterministic. So you could be doing something really important and it'll just come along and go, hang on a minute, I just need to clean up. And there's a great video on YouTube of a massively multiplayer online space shooter game where all the missiles and everything just freeze for about 2 seconds while the server runs a garbage collection sweep, and then they carry on again. And so they had to work on that. And what's come out of that is span of T, which is in system.buffers. And you can use it with .NET 4.6.1 applications and other applications. But in .NET Core 2.1, it's really powerful. And the reason for that is what they've done on the inside. And because it's .NET Core, they've been able to spread span all the way through the other APIs. So all the Stream APIs and the SQL clients and the HTTP clients, they can't just run around changing those in full-fat desktop.NET because they will break the world. But in .NET Core 2.1, we've got all these weird bits of code saying things like, where's my laser pointer? I don't have a laser pointer on this one. That would be why that's not working. But yes, so we've got this, when you wrap an array in a span, they use these weird by reference things and unsafe things and get raw SIS array data and so forth. And they're actually kind of doing horrible things inside the memory system of .NET and pinning things so that they don't move in memory so that they can be operated on really fast. And this allows you to write code that allocates very few objects. And as an example, I have been working a lot with InfluxDB, which is a time series database. And the official InfluxDB client, every time you write a metric to Influx, you have to pass it 2 dictionaries that you have to create. One is a dictionary of fields, one is a dictionary of tags. They then take those dictionaries and they turn them into read-only dictionaries for reasons I don't really understand. And then they do a whole bunch of to-string operations while they're formatting that to a big string builder, which they then send up. And so every single metric causes about 8 or 9 allocations. And if you're doing metrics properly, you're writing hundreds or thousands of metrics a second. And so the garbage collector is going to go nuts. And so I thought, I need a better client. The span thing's just come out. And so I wanted to build a span thing. And I am going to have issues here. There we go. This could be fun. Let's see if I can actually sort this out before I do this. Yes, that's what I need to do, isn't it? WinP and duplicate. Nope, I'm going to have to go in because now it started duplicating things on the little screen as well. Display settings. Right, so I have got, according to this, I've got one display. Duplicate desktop on show only on one. Keep changes. Nope, duplicate desktop on help! I've broken it. I'm going to unplug that. That'll make life easier. Right. So here we go. This is my code for InfluxDB, and this is why I like using VS Code for presentations, because you just hit Control+, because it's basically a browser, and so I can just make things bigger. So yes, the way I've written my client is that there is an InfluxDB client, and it uses the array pool. So there is a built-in pool of arrays that is managed for you, and you don't have to worry about it. And you just say, give me an array from the array pool, and I'm going to do some stuff with it, and then I'll return it to the pool when I'm finished. And the base class library takes care of all of that for you. And so this InfluxDB client rents a nice big, like 64K array from the array pool, and it gets that back. And then all the various metric writers say, hello, I've got some information. And the client manages all of these, so all these requests to write some information come in, and it marshals them all onto a single thread, which it does using a blocking collection. And then it goes through them on a dedicated thread, and it says, right, you write your data here. And it passes a subset of that big array. So it goes, I think you probably only need about 1K to do this, so I'm going to give you a 1K chunk of this array as a span, and you write what you need to write into that, and then tell me how many bytes you used. And then I'll mark those as used, and the next time somebody wants to write something, I'll give them a chunk as a span that starts from where that last one finished. So we're not allocating read-only dictionaries and lots of strings in order to be able to write to this thing. And it gets even funkier because we have field helpers here. So metrics, they can be integers, they can be floats, they can be doubles, they can be strings, they can be time spans, and we want a way to format those onto that span of bytes as UTF-8 encoded strings without having to go to string and then encoding dot to UTF-8 bytes with those things, because strings are objects and strings are allocations, and even if they don't live for very long, they still have to be cleaned up. And so we have here, if I try and find one a bit complicated, if you write an integer to this span, it comes down to here, and we have this UTF-8 formatter. And what UTF-8 formatter does, this is included in the system.buffers. It's under system.buffers.text namespace. And this, you can pass any of the primitive types from C#, so ints and bools and various other types. And you can pass those into UTF-8 formatter, and it will turn them into UTF-8 bytes on the span that you've given it without any allocations at all. And you can write that if you've got a spare couple of days to cover something like that with enormous unit tests, but it's built in now, so we don't need it. And so these writers, they're using anonymous objects that are passed through as the metric. So we've got that one allocation for every metric that's written. But then apart from that, it's all done, there's weird reflection helpers in here and stuff that do typed reflection so that you don't actually have to create an object and then convert that to the right kind of value. So this is all done with structs, primitive types, and there are no allocations anywhere throughout this process. And when I benchmarked this against the official InfluxDB client, I thought, it'll probably be a bit faster. It's 1,000 times faster. And it uses 1% of the memory of the official InfluxDB client. And when I took that into my customer who I'm currently working for and said, we were having performance issues with the performance measuring causing performance problems? And they said, yes. And I went, I fixed it. And they said, cool, now do this, because that's programming. And they started from the beginning again. What's the key press not to start from the beginning? Shift F5, thank you very much. See, can't work PowerPoint. Right, reason number 2, Blazor, or Blazor. Has anyone used Blazor yet? It is just, it's nuts. So Steve Sanderson, who's the guy who wrote Knockout.js and the guy who wrote all the JavaScript services for .NET Core so that you can do server-side rendering with Angular in your .NET Core application. And he'd kind of done those things, and he was just going, I'm bored. I wonder if I could run .NET code actually in the browser as WebAssembly. Now, what you might try and do with that is you might take a C# application and transpile it to JavaScript, and people made efforts to do that. But no, what Steve did was he found actually a very old open source implementation of .NET called .NET Anywhere that somebody wrote, just one guy's project. And he ran it through Mono's compiler that that transpiles IL code to WebAssembly code. And then he downloaded that into the browser to see if he could actually run the .NET framework in the browser. Because that's what Blazor does. I hadn't realized this until I actually dug into it. But it has transpiled MS Corelib and system.private.runtime and system. Everything has been converted to WebAssembly. It downloads the entire .NET runtime into your browser. Do not run this on anything except an intranet, okay? Because over the web, oh my God, that's slow. But it works, and it means that there is no .NET code that you cannot write, that you can write, that cannot be run in Blazor. Don't test that because it's still fairly new. It's on 0.6 at the moment. Here's a Blazor app, and this is just a standard Visual Studio thing here, and we've got some pages, and this is just Razor. We've got an app page to tell us what the URL of this page is. We've got this survey prompt object here. That goes over to this survey prompt control here, and it's just Razor. We've got strong the @title. We've got some functions down here to have a property and so forth. And if I run this very slowly and hit F12, so we get the network information coming through. My fans are spinning up. So yes, there we go. You can see here that we've got my Blazor app client.dll and mscorelib.dll, all 666K of it. Ooh, it's the number of the beast. I knew it. Steve Sanderson. There's an anagram of Satan in there somewhere. But yeah, this lets you build, this is the equivalent of building an Angular application or a React application or a Vue.js application. And it is still in the very early stages, but it's gone from being something that Steve Sanderson was going, hey, look what I can do, to Microsoft. This has actually been pulled in. This is an official Microsoft ASP.NET Core project, which theoretically is going to be fully supported next year. Okay, and it is completely nuts, because I'm going to stop it because I've got so many things running on here. I'm going to run out of memory. So yeah, we've got all that stuff there, but we've got a service here. This is weather forecast, and this weather forecast library is a .NET Standard 2.0 library, and it works, and you can pull it in and it runs. And people have been mucking about with all the .NET Standard capable libraries that are on NuGet and pulling them into Blazor apps and seeing how they run and what things they have to hook up differently to get them to work. And it does work. It's really quite bizarre. Look, they've even, they default to storing the temperature as a proper number, and then they convert it to that weird American number. Really precisely as well, look at that. But yes, what this means, pick up my litter. What this means though, because the other thing with WebAssembly, it can do things that just general JavaScript can't. It works at a very, very low level. And so you get better performance for certain types of operation. So if you got the image sharp library, for example, you could download that into the browser, and then you could do image manipulation in the browser, tinting, coloring, adjusting hue, saturation, value, applying Gaussian blur, all those different things, which are far too complicated and difficult for JavaScript to do. You can do those in the browser by importing the image sharp library, which is heavily optimized for doing that. And it actually means you could create something similar to Photoshop running in the browser, and let yourself go nuts with what you could do on that. That's really exciting. As well, Shift F5. There we go. So that was just the demo app. You can go to blazor.net/docs/getstarted.html, and that will show you how to work with that. It does work best right now with Visual Studio 2017 15.8 running on a Windows box. So all you Mac users, it's time for Fusion or Parallels or Boot Camp. For me, it's time for the next thing, Avalonia UI. So we can create .NET apps that run in the browser. Technically, that means we could create .NET apps and then wrap them in the browser and then run them in Electron. But apart from the single exception of Visual Studio Code, Electron apps tend to do horrible things to your PC because underneath they're Chrome. And Chrome is going, oh, look, an italic tag. I'd better start a process. Wouldn't it be nice if we could create cross-platform apps that ran on Linux and Mac and Windows without using up all of people's available memory to the point where their computer starts looking across the network to see if it can borrow some, and without having to learn Qt5 and C++ because, oh my God. Now, we can because there is Avalonia. And this one, I have a proper demonstration application for this. Is anyone using Kubernetes? I'm working with secrets in Kubernetes. It's a massive pain in the something. It's just complicated, and I wanted an easy way to work with it, and I thought I'd write a web application, and then I was looking at Avalonia, which is a cross-platform XAML-based, so it's like WPF, but it runs on .NET Core, which means you can build the application and you can run it on Linux, and you can run it on Mac, and you can run it on Windows. And again, this is something that's still in its early stages, but they're working really hard on it, and it's going really, really well. So I have got this application, which is a desktop GUI application that shows you the kube configs you have available and then pulls down the secrets and then will have a UI for managing those secrets. It's just I'm demonstrating it with live stuff, and so I have disabled the UI on this copy that shows you the actual values of the secrets because they're all my connection strings and you guys have got smartphones. And I know you're a bunch of hackers. I just know it. So yes. But this is, it's called Secret Squirrel, and it starts very similarly to a .NET Core application. We have a class of program. It's got a main, build the Avalonia app, and start it here. It looks almost exactly like a an ASP.NET Core application, in fact, except that it's got XAML in it, and it has got XAML just like WPF. They haven't changed things that didn't need changing. They have changed quite a lot of stuff under the covers to make it more performant. So things like dependency, graphs, and so forth have been simplified. But it's got a grid, and it's got text blocks, and it's got drop-downs, and everything else. And if I drop down to here, and I'm going to go in. cd/labs, Kubernetes, secret squirrel, and do .NET -- version. You can see I'm running .NET 2.1.403, which I think that needs updating, actually. No, it doesn't. Anyway, I can just do .NET run. And that's going to go off, and it's going to build stuff. And please don't do a restore, because the internet is not good. And eventually, this will cut. There we go. So you can see I have a .NET Core application here. You can see my logging going out to the console there. And here is my list box with all the secrets. And you can see I've got like my slide storage key and my Twitter key and so forth. And in the actual version, there's a UI on the right-hand side that shows you the values of things within those secrets and lets you edit them and save them back to the client. So yes, so that's pretty cool. And that application, I can clone that application onto a Linux box, and I can run it on there, and Avalonia takes care of turning that XAML into GTK code. And if I run it on Mac, it takes care of turning XAML into Cocoa. So yes, it's all done for you. And if you go and look at your task manager and check your processes, you'll see that they're all just trundling along on the bottom just like they should, because it's a .NET Core application and not multiple Chrome processes. So that's pretty cool as well. I'm quite happy with that. I can write cross-platform applications in .NET. If I could get a designer to come and help me, I could write cross-platform applications that didn't look like CAC. But I'm constantly doing these talks and going, if any designers, and I think designers just look at me and go, yeah, no. Don't know why. Let's go back over to the slides. So yes, that's Avalonia, and you can go to avaloniaui.net to find more information on that. But it's a very active project, and it's a lot more mature than what I just demonstrated. Someone has actually written an IDE for Avalonia in Avalonia, which is an ongoing project. But you can go and look at these people's code and go, that's how you do that. So there's lots of fun stuff going on in there as well. Okay, next reason, Core RT. Who doesn't know what Core RT is? Okay, excellent, good stuff. Core RT is an ahead-of-time compiler for .NET Core. So .NET Core has a just-in-time compiler. And actually with .NET Core 2.1, we have an optionally enableable. Enableable? Don't worry, Swedish people, that's not a word. Your English is fine. You can turn it on and off again. Tiered compilation thing where it'll do a quick JIT for the first time it finds code, and then it'll do a slower but better, more optimized JIT the second time or after it sees that code is getting called a lot, it'll rebuild it in a more optimized way. But wouldn't it be nice if we could just do that compilation step once and do the sort of optimize the heck out of everything on every single line of code that we've got in there, and then just ship that to customers already compiled, so we don't need to send them a JIT. Because effectively, when you distribute the .NET runtime, you're going, here you go, here's the compiler for the semi-source code I'm about to send you. And what Core RT does is it uses ryujit, and it runs through the code and it says, do the second tier compilation on all of this stuff because I've got some time to spare, and then statically link all of that into a single executable. Okay? That single executable is a .exe file on Windows, and it's just an executable file on Linux and Mac, and that contains the .NET runtime, the CLR, the garbage collector, MS Core lib, everything else you've got. It actually contains way more than it needs to at the moment, but they're working on doing tree shaking so it can go, you're not using that, so I'm going to ditch it. We're getting there. It was supposed to go sort of RTM at the same time as .NET Core 2.0 came out. It is actually still on alpha, and it's only available from the .NET MyGet repository. But it's fun. And it's one of those things where you can go, I wonder if this will compile with Core RT. And if it does, then yay. And if it doesn't, then just try again in a couple of months, and maybe it will then. So this is basically how it works. The user writes their code, and then that goes through the Roslyn compiler, which turns your C# or your VB.NET or your F# into managed IL. And then we've got the core framework, which is running over on the side there as well, which is all Microsoft's code that supports your stuff. And then Core RT, because there's lots of stuff in the normal .NET Core CLR that doesn't make sense in an ahead-of-time compiled environment, not least reflection.emit. You can't do reflection.emit anymore because that uses the JIT, and the JIT's not there. But there's a whole bunch of other stuff that can be optimized differently for an ahead-of-time compiled environment. And so Core RT provides an alternative base runtime for .NET that works in that way. And then it goes through this whole process. It looks at the dependencies and it says, do you need that and do you need that? And it starts trying to throw stuff away. It's actually very, very enthusiastic about throwing stuff away, and you kind of have to tell it not to a lot. And then it goes through, there are 3 options for compiling it further. It can go through ryujit, which pushes it through something that's based on LLVM, called Object Writer, which then produces a native .obj file or a .o file on Linux and Mac, and then that all goes through the linker and links with the Core RT runtime stuff and produces your actual executable. There is an alternative path where you can go through C++ code gen, which just very stupidly converts individual IL calls to an equivalent C++ version. You might think that would be faster because of optimized C++ compilers. You would be wrong because the C++ code that is generated is terrible, really bad. And you can also pipe it through a WebAssembly compiler, which will produce WebAssembly. And theoretically, Blazor, once they get this working properly, Blazor will start using Core RT instead of .NET WebAssembly, instead of the mono version. So, very simple hello world demonstration of this would be incredibly boring, so I'm not going to do that. Instead, I thought, why don't I see if my Avalonia UI application, Secret Squirrel, which uses various tricky libraries off of NuGet, will compile with Core RT, and I can turn it into a native application. Let's see, shall we? So if I go... So yeah, I need to show you the code. Right, here is my secret squirrel.cs proj. In order to enable this native compilation step, I had to add a reference to Microsoft.NET IL compiler. There. I have a NuGet.config that points at the .NET myget to pull that in. And I also have to create an rd.xml file, and I put this ILC arg in because it helps with debugging. Those are the only changes to the CS proj file. I don't need any changes to my code because the whole point is that your code should just compile and run. If I just did this, then the first time in the application that it was running, where it wanted to create an object, it would go, I can't create an object because it's missing the metadata. And so what you do is you go through this process of building it, running it, it tells you which object it's missing metadata for, and then you slowly and gradually add it into this rd.xml file. You start off by going, right, every NuGet package DLL that we've got, just assume we require all the types from there for now. We can optimize it later, okay? So we got all the Avalonia things, we got MS Corelib, we're going to need everything from there. And then we get down into some slightly more complicated things down here. So the Bouncy Castle crypto library, which does X509 certificates and that sort of thing, dynamically creates arrays of enumerations. And the compiler doesn't see those calls in code and say, oh, I need to include that type. So when it runs, it hits the bit where it says enum.toArray or whatever it is, and it goes, oh, I don't know how to create that type because I don't have the metadata for activator.createInstance. And so you go in and you go, right, you're going to need this one, and this one, and this one, and in the JSON, newtonsoft.json, you're going to need this collection wrapper thing here. And because collection wrapper is generic, you have to say you're going to need a collection wrapper of v1 secret from the Kubernetes client, which you will find in the Kubernetes client library. Otherwise, when JSON.NET tries to deserialize the JSON and turn an array of something into a list of v1 secrets, it again will go, remember manual testing where you had to try and manually go through every single path in an application before you could be sure it worked? Welcome back to that. But the payoff is quite spectacular. I'm going to cheat a bit here. I'm going to go into the release folder and the .NET Core app and the Win64 native. Right, there. Secret squirrel.exe, an entirely self-contained, natively executable. I could give you that exe and the native DLL that goes along with it, and you could put it on a Windows 7 64-bit or greater box without .NET on it. Or without, it wouldn't touch .NET. It's got everything it needs inside that single executable and that DLL. Eventually, if you can find the linkable, statically linkable object library for Skier Sharp, you'll be able to statically link that in as well. And then you've got that thing that Go does, where you go, here it is, it's executable, everything's included. And I'm not going to run that one, because that's a release build, which has bugs that the debug build doesn't have. So I'm going to run the debug build, but here we go. Watch how quickly this starts compared to the .NET run that I did earlier on. Really quickly, because there's no JIT happening. So literally all it was doing then was initializing the XAML stuff and loading it, and if the internet's working, attempted to read or write protected memory. Okay. But yes, you get all those proper errors and core dumps and things like proper C++ programmers get. It's crashing, but it works when it doesn't crash. So yeah, I'm not saying it's ready now, but it's getting there, and it is getting a lot more investment in it now, because something exciting that's happening next year is .NET Core 3.0 is coming out. And .NET Core 3.0 supports WPF, and it supports Windows Forms, which means you can port your existing WPF applications over to .NET Core 3.0 and get the benefit of all these runtime improvements and performance enhancements and everything else in a WPF application or in a Windows Forms application. And one of the things they announced at Build was that it would be possible to compile those natively like this, which I'm assuming means they're going to use Core RT to do that, which I'm assuming means they're going to create a slightly better experience than access violation exceptions with no stack trace. I am in the debug pod. It worked. Literally, I was sat at the back of the room and I tested it and it worked. Come on, one more try. Go on. Request complete. Nope, it's going to crash. Sod it. But yes, so this is going to become a viable part of the .NET toolchain, which means it already works really well for very simple console applications, and they trim down quite small. You can get them under 10 megabytes for an application, which is fairly comparable to what Go can do. Okay, so we also have Xamarin Forms, which is very exciting, but who here's done some Xamarin work? Yeah. Xamarin Forms, it looks a lot like XAML. You create an application and it's got an Android application and it's got, so here we have the yay.xamarin.android. This is where you put all the Android-specific code that only, so resources and so forth have to go in there. But all your XAML and your view models and your business logic and your models and all that sort of stuff goes into a shared library, which is a .NET standard library. And that gets pulled in, and then it's converted so that it renders to look like an iOS application on iOS, and it looks like an Android application on Android, and it looks like a really bad Mac application that didn't have any designers involved on Mac, because you want to make Mac applications, you have to make them look pretty. They don't like ugly applications on the Mac store. But yes, you can do that. I would try and run this, but it involves spinning up an emulator. Good news, by the way, there is now an Android emulator that runs in Hyper-V. So if you're also using like Docker for Windows or something that requires you to use Hyper-V, you can now emulate Android. You still need to have a Mac in order to build for anything else. But yes, Xamarin Forms is there. And it's very cool. There was going to be a demo, but I'm not going to do that. We also have XAML Standard, which is like the XAML version of .NET Standard coming out soon, and that's going to make everything the same names in all the different runtimes, if it ever actually arrives. Last commit on the GitHub repository 11 months ago. But you know, they'll get there. So finally, with .NET, the final reason that you can stay with .NET and still do cool things is you can write code that runs on the Xbox One and the PS4 and the Nintendo Switch and all sorts of mad platforms. You can create games that download as WebAssembly and run in the browser. And I'm reliably informed that it's incredibly cool, but I don't really know. So I'm going to ask my daughter Willow if she wouldn't mind coming up on the stage and showing you how Unity works. Please welcome Willow Rendle. And I will stay here to do the complicated alt-tabbing. Okay, you all right?
Nervous. This is a big room. Very big room. All right. Hi, everybody. I'm Willow, and I'll be demonstrating Unity. So, as you can obviously tell, this is a clock. I'm going to be making this tell the time. Okay, Dad, the mini screen's dead. The mini screen's dead.
Let's plug it back in and see if it breaks the world. Yep, it breaks the world. Just manage without it. There you go. Look, there's your crib sheet there.
Way to reveal all the secrets. Okay, so to make this work, we're going to have to, first off, this clock is made out of, what you can do is create different shapes in Unity. So this is made, the face is a squash cylinder, a bunch of rectangles that have been stretched out like this, and then obviously the hands are also rectangles. Right, so there you go. So we're going to make another script here. We're going on to C# script, and let's just call it clock. There we go, that works. All right, and then double click on this. Whenever you're ready. Come on. There we go. Okay. So, if we go in here, we're going to have to make a script to try and make a function. So, what we're trying to do here is make it connect with the time, which you can do. So, if we go into, I think, update, and then go. Wait, first off, completely forgot. Oops. We need to drag this so it connects with the clock. So if we go onto here and then make sure this is all functioning correctly. Okay. Right. So this crib sheet's not very clear. I'm very confused. Sorry, I'm confused. I don't get that. How does that work? Okay. So if we do this, okay, and then we do like it's like this. Oh, I'm doing this wrong. I'm so confused.
Sorry, nervous.
Yeah, very nervous.
Right, let's plug this back in. Oh, for God's sake. No. Okay, there you go.
There we go. All right, we're back. Sorry about this. I am literally shaking on here right now. That's not how you spell variable.
There you go.
We're back. Sorry about that. Okay, here we go. Properly doing it now. Okay, so do another one. Right, so if we're going to do it, we have to do our... It's not how you spell degrees. You rubbed off on me, Dad. So if we're going to do for the hours, obviously it's a 360, so we do 30 for each one. Maths, more than he can do. We're go and then float. Okay, then... Ah! Why isn't this working?
Mouse working?
Yes, it's not
I
working.
told you, learn Vim. She will. No daughter of mine will be using Emacs.
What?
Don't worry about it. It's an operating system. It just needs a good text editor.
Okay. Okay. Right, now the other screen's not working. This does not function. Right. Where is it? Where is it? That. Okay. There we go. Right, and then we do the same thing for minutes. Ah! And then obviously we're going to have to change it to do 6. Sorry, I can't type and talk at the same time. Very challenging. And then last one, 4 seconds. There we go. Semicolon. Right. Now we've done that. If we just save this and then go back into Unity and then Control P. Has this worked? No, it hasn't. Damn. I need to drag this onto here, don't I? Okay. Thank you. Right. Now, if you go up to the top, we don't need this. Get rid of that. Right. Rewrite. Where's the tab? Right. So, we're going to need to connect it to the hour hands now so that they actually can link together. So, hour hand. Then minute hand. Lastly, seconds hand. Very repetitive, but I can't actually do anything else except for repetitive, as you can tell, so it works for me. Right. And then last bit before hopefully it will work.
I still have to teach her the programmer's most important skill.
Was?
Copy and paste.
It's cheating. I don't like cheating. Well, I technically am cheating, but...
I think you've got a comma there instead of a dot.
Can't type. Can't spell. Can't do anything. And a very difficult word to spell. Quaternion. There we go. Spells it. Quaternion dot Euler. Euler. Sorry, it's pronounced Euler.
It is.
Yay! There we go. And then we've done that right. So that's supposed to work.
No, you need to pass the parameters in, don't you?
What?
You need to pass the arguments to the Euler.
Oh. Ah! Why can't I remember anything? This is your fault. We were on that plane for hours. I have forgotten everything. Now the mouse isn't working. There we go.
It is working.
It's not going across the screen. Come on. Yay, there we go. Mouse is back. You can go away now. Right, so then we do, why is this capital? There we go. Then we have to do our degree since it's going round the Y. Then this. And here we go for a lot more repetitive stuff. Yay! Right. Rapid typing. Not my forte. Right. degrees. Sorry, I refuse to copy and paste, so you're just going to have to endure this. I defy you, Father. I defy you. Nearly done. Nearly done. There we go. Yay! Finished. Now this.
You've got another comma there.
Oh, for God's sake!
Hang on. There you go. I fixed it for you.
My hero. Yield
Right.
tabbed. Okay.
Right.
I can do
Okay.
this.
I know, but I'm doing it.
Why?
Because I want to.
Make you feel special.
It does make me feel special,
Good
yes.
for you.
I have so little, so little going for me. That screen's on the wrong side. Okay, there you go.
Right, Control P. Now it should work.
No, it won't. Why won't it work?
Oh.
What haven't you done?
Oh. Okay. Sad. I've done that. Oh. Oh, I see. No. That. Oh, you need to drag these into here. I forgot. Not my fault. Right. Am I done now?
Yeah.
Thank you. Hey!
Okay.
That took longer than it meant to. That went very wrong.
Yes. So, explain to us why this. What's that doing there? Where did these come from?
Well, when we were doing when we went into the Visual Studio here, when we were writing it out, the public transform here would mean the public would show it up on the actual Unity platform where the script is, so that once you linked to the actual things you wanted to turn and you just dragged them into there, that's what would happen.
Okay. So yes, did you get that? Thank you very much, Willow. We are bang on the end of the session. Is it okay if we have a couple of minutes for questions, if anyone's got any questions? And if any of the questions are, how did you get your daughter into coding? I didn't, I just let her. So yes, but no, any questions about anything from this talk? If you want to see anything in more depth, we will be hanging around all afternoon. We'll be over by the lightning whiteboards area in the corner of that room there, so do feel free to come up and see us. And we got a question over from this. It's going to be for you, isn't it?
It's actually for you.
Oh.
I'm curious about the Blazor.
Blazor, yes.
Yeah. What makes it better than ActiveX?
What makes it better than ActiveX is it doesn't require Internet Explorer 6. No, WebAssembly is a standard. WebAssembly is something that has been developed and agreed upon and reached by all the major browser vendors. So Chrome, Safari, Opera, Firefox, Edge, all the current evergreen browsers now support WebAssembly to some degree. Most of them have got full support. And so your browser application, it will download all those DLLs and it will run them in any modern browser, including mobile browsers and everything else. So that's why it's different. Thank you. Good question, though. Got me a laugh. Any more questions? Yes? Avalonia UI, yes? Yeah. Yes.
Combined. Does that mean that Avalonia will be obsolete?
No, it doesn't, because, so the question was, will .NET Core 3.0 supporting WPF and WinForms make Avalonia obsolete. And it won't, because the thing with WPF and WinForms is that they are both managed layers over Windows APIs. And so .NET Core 3.0 will let you create WPF applications and WinForms applications, but those are Windows applications. So you're not going to be able to just pick them up and run them on Linux and Mac, because the underlying APIs are not there from the Win SDK. So Avalonia will continue on and probably get better support, and they'll be able to kind of go, so cross-sharing of XAML controls and so forth. But it's still going to be very useful for building cross-platform applications without Electron. And hey, that's a target. Okay, right, it's time for lunch, I think. So I'll hand you back to Madeline. She will explain what's happening next. Thank you very much from me.
Thank you.
And we'll see you later on. Cheers.